safety aspects of this. You are dealing with high voltage charged elements, so that whenever you go in to service this thing, you got to make sure that everything has been grounded out and secured. And if you go into the actual grid section where the probes are, there's actually a grounding stick that he wants you to use to ground out the system before you ever go in there to do any maintenance.
There's a key system too.
Key system.
So you see up at the top, above the disconnector?
Oh, right there.
So once that's down, you take that key,
Yeah.
and where that disconnector is, locks there to.
Locks over here also.
Yeah, and then also the system itself, so you're forced each time to take the steps.
Another aspect of the WESP is this fogging system that we put in, and it's actually located on the inlet duct to the WESP. It's about 25 feet downstream of the WESP, and they went through a lot of trouble to do this right, because vendor, our experts wanted it to be an air atomizing nozzle. So you have potable water, not plant water. Potable water, we strain it really well, and it's comes in here, and we got compressed air at 70 to 100 pounds. We can vary the pressure of both the water and the air through the regulators we have on here, pressure regulator here and here. And basically, what we want to create through this nozzle is very fine mist. Matter of fact, it's just like a fog. If gentlemen have told me that if you put your hand through it, it won't get wet. It's such a fine mist. It's very fine mist.
And what's the ratio of water to air?
Water here.
I mean, we can operate the equipment, we gotta figure this out.
This is gonna actually get field adjusted.
Field
This
adjusted.
will get field adjusted, so we just start, it's been one of the things that's gonna get done.
So that the operators will not be touching it then, it'll be.
The West guy will be there during the first
Set it,
startup.
forget it.
No, you get the monitor. Once you set it, you know, because you talk about the nice screens on here too, right?
Yeah, you're gonna actually, if you set this regulator and this one here, you can get different flow rates and different droplet sizes through the nozzle.
I mean, you get rotometers and stuff on there, I mean, we gotta adjust it, we gotta be trained on how to adjust it.
Which they will.
We will be.
They'll be out there in the field, the guy will be out in the field, he'll be sitting up.
This is a detail of the actual irrigation nozzle. Shows you where the air and the water come in through this arrangement here. We made this with union, so this can be taken apart and cleaned. This whole assembly can be taken out of the ductwork and cleaned if you have to do so. And the nozzle itself is right there. There.
We'll see what the size of the nozzle.
Orifice size. It's very fine.
Very fine, so chances are it's gonna plug up there.
Well, we've provided quite a bit of a lot of straining and filtering of both the air and the water on the inlet, so hopefully keep it going. Like I say, it's potable water also. This shows you the actual where it's installed, shut-off valves up here, and how it comes into the ductwork here through this 6-inch diameter nozzle here, all bolted up.
The little shut-off valves have to be closed when we shut the unit down. I mean, it's an issue, it's 30 feet in the air, it's kind of tough to get at, that's what I'm just thinking of.
Valves upstream too.
Yeah.
There's another ball valve
Yeah,
upstream.
there's a whole bunch of.
That's so you get
I have to look at it more closely, I didn't realize the orifices were that small.
Is there one at bypass?
Could be a bypass, I've only looked at it.
The SIM system, continuous emission monitoring system, we didn't do too much with this system. We did take it off the third unit, third RTO, because it's just doing odorous air now on that third RTO, so they didn't require monitoring, so we only have monitoring on RTO 1 and 2. But we did have to tie the SIMs into the SCADA system. And you still have opacity monitoring and NOx, CO, and oxygen. CO, nitrous oxides, opacity, oxygen, wet and dry. Basically what you're monitoring. This was another thing that we did, we moved the makeup air damper on the RTO from, it used to be on the ductwork over here, and we moved it over here because we wanted to put isolation valve here so that we can get those bypasses in. So that was another change that we had to do. Okay. So flue gas, here you have a multiple hearth furnace over there. This is the breeching, that red portion here, where the flue gas comes out of the furnace, and it goes down into the Venturi scrubber, across into the tray tower, and then it comes up over here through this duct here into the ID fan. This ID fan now, it's a variable frequency drive, and the flue gas comes out over here and goes around the ductwork through a mist eliminator. Out of the mist eliminator, it comes through this vertical duct here, around over here, and it goes right there. You see the nozzle, the fogging nozzle for the WESP, the wet electrostatic precipitator, up there. Right over there. Fogging nozzle for the wet electrostatic precipitator. Then hang on a minute. Then it goes down into the ductwork, comes down over here, and it goes down into the WESP, the wet electrostatic precipitator. Yeah. Flue gas recirculation duct here, coming off the top of the furnace. Notice it's all insulated on the outside, and right here is where the odorous air comes in. We have a automatically controlled damper on the odorous air supply, so that can be changed and varied depending on the oxygen level in the flue gas. Okay.
Is this valve modulate or is it
Modulate. Yeah. Because you can adjust how much odorous air you put in. There's an expansion joint on the bottom here to allow the duct to expand and contract from the heat, because it's heating up a lot. This is the FGR fan. You can see it's a tight fit, wasn't it? Very tight fit. Here you got the temperature sensors on the bearings over here. This here is the see the water jacket coming in. The water's coming in over here for the water jacket. There's a water jacket to keep the shaft cool. Okay. These here are there's a vibration sensor here. Okay, vibration sensor, and that's temperature sensor on each of the bearings. You know, you got 1 and 2 over here. You got another one over here, and it'll keep track of those temperatures right here.
Which ones are these? One's vibration or one's...
These are both temperature.
Oh, temperature.
Two temperature. You got a vibration one's right over here.
Oh, okay.
Viltronics. Okay? So you got the vibration there. This is there's a control valve here, limit torque, flow control valve. Okay? That's a pressure reducing valve because they wanted to see so much pressure at the nozzles. They wanted to reduce it down.
What's the setting like that?
I think it's about 30 PSI.
We got around 60 in here now, something like that.
Oh, that's good. Yeah. And you got a manual shut-off valve here. Here's the insulator compartments on the WESP. Okay, there's one on this side. Covers off over here. Okay, yeah, we'll go over here.
What's that do right here?
This is
It's
it's an insulator, yeah. You see, now this is an insulator. Because this part here, this whole grid would have a high voltage on it. You couldn't touch that.
Right.
And you wouldn't want to ground it out. So you gotta insulate that from any, the only thing it's touching is this insulator. To insulate it, you see? Now you don't want to get this thing dirty either. You got to keep these things clean, or else you'll arc current right across the insulator.
Oh wow! I
Yeah.
didn't know that.
Yeah. And
Once it's all bolted up, it still can get dirty from backsplashing water.
well, the flue gas itself, the dirt
Oh,
can have
okay,
dirt in it. So we have this purge air system that supplies air in there. Oh, it's hollow, yeah. Air can come out of here. Air can come out of here. See, we're blowing air through.
Yeah.
And we've got a slide gate to adjust the airflow too.
Oh, okay.
Okay? And we have heaters too. It measures the temperature of this air so that we can turn this heater on and off. There's a heater right in here that'll actually heat that air coming up. Okay? Yeah. So that way we can give it hot, heated air to each of these compartments. So here we have a redone burner train. Okay? This is your gas line coming in. Pressure sensor here. This would be a high pressure sensor. This is your automatic shutoff valve. A valve down here with an electric actuator. Kind of like a solenoid actually. Okay? And then you go to a low pressure sensor here. You notice you've got these taps here. These leak test ports for checking the whether or not this valve is working. You would close this. It's closed now. You'd put a glass full of water here, open this up, and see if you had any gas coming out of there to check to see if this was fully closed. You know, that's leak test. This is the regulator. This modulates the amount of gas that's coming through that you're going to fire. Okay. It gets an impulse signal. See this line here? This line here goes to this line. That's your air line. The big 3-inch line is your air line. So, the combustion control works by modulating this airflow. First it gets a signal to modulate that butterfly valve on the air line. Changes the airflow, okay? The change in airflow is sensed as a change in pressure through this impulse line here, which goes to this regulator, modulates that damper so that it responds by giving enough gas in proportion to the amount of air, okay? So the control is first to the air line, and then the gas line responds to it. And all burners work that way, because you never want to add gas without air. You always want to have enough air. So the flow of gas responds to the amount of air. And these devices here are for fine-tuning of the gas flow. The IFCO people are they'll adjust these things. You don't have to worry about them, okay? They're just fine-tuning. The gas comes through, goes into the burner here, okay? So that's your gas. Your oil comes in down over here. Oil line, these are dual fuel, of course, burners. Oil comes up in this line here, yeah, the red line, comes over here, small pipe. Filter, there's a gauge, there's a shutoff. This is your automatic shutoff valve now for your oil, okay? Oil line, then it goes to a regulator. Regulator here. Over here, no, this one here is just a pressure reducer, okay? Because the oil's at high pressure, you gotta get it down. This one just lowers the pressure reducing. This valve here, this is the pressure regulator. This one here does the same thing. There's an impulse line, again off the air line, so it does the same thing as the other one on the gas did. This regulates the flow of oil. Oil goes through here, here, comes up over, oh, here it goes. Oil like this, down through here. And then it finally goes through the sensitrol valve here. Gets it into the burner, okay? So that's your oil line. You have a pressure, you got a pressure sensor on the oil line also. There's a pressure switch there. You got to have sufficient oil pressure, okay? There's also a pilot line. There's a pilot line down here too. We go back over here, right over here, this is your pilot gas. Comes in, you got another solenoid safety shutoff valve for the pilot gas.
That comes over. You got another, there's a, this is a regulator also on the pilot line, very small regulator, and it gets vented. It gets vented back to the mixer there. This pilot line goes in over here. Goes in over here, and it gets mixed with pilot air. Air comes in on the other side of this line over here, and they get mixed right here. Go through a little venturi here, and then it goes. The pilot gas goes in over there into your pilot. Okay. Here's your spark plug for actually igniting the pilot mixture. So those are your basic lines, you know.
Yeah.
How they work. Right.
I scan it all.
This is your plant, your potable water. Potable water. You got a backflow preventer, and this potable water is used in two places. It's used on the jacket for the FGR fan for cooling, and it's also used in the fogging nozzles.
This is gotta be the mist line here.
Oh, this one is the mist line.
I'd say so, because this one's a solenoid for the FGR fan.
Okay. Yeah.
Okay.
This one here goes to the fogging nozzles.
Right.
Yeah, fogging nozzle. And
this would be, this is the, it should be the return, the water that you dump through the shaft cooling water.
okay. Oh, the return.
Return on the shaft cooling water, yeah.
Return on the shaft cooling water.
Well, like the other
Yep.
one's on the floor.
I got you. Yep.
Drain.
Okay. All the burner panels, Honeywell,
So it's on oil or gas.
oil and gas selection here, start, stop, flame safety. The purging of your burners when you initially fire them off is done here automatically, you know. Yeah. Burner on. You'll select your fuel.
Tells you what's going on. I can see that over there.
Yeah. Yeah. Ignition transformers, I believe, on the burners. They had to mount these separately. Prior, they were able to locate these inside the panels. But ignition transformer for the burners. Okay. Yeah, they wanted to remotely locate these from the panel. Because this is the Venturi throat mechanism here. Okay, we replaced that whole damper section all the way from here, this flange, to that flange is all new, okay? Replaced that piece. And the actual damper mechanism is over here. It's this rod, this device right here. The shaft goes right through, and there's a damper in there which will turn that shaft will turn that damper. This is the fire water, the backup water supply. They replaced the gaskets too on these things on further on down on the scrubber system. Gaskets. This is the FGR here, recycle duct. Another expansion joint here. We put expansion joints on either side, top and bottom of the duct. Above the fan and below the fan are flexible expansion joints. This is insulation access door here. We had to. It's very important to insulate that duct because we didn't want to get any condensation. We want to keep the steel hot on the inside, or else you get acid gas condensation, and the duct would corrode. So the insulation is very important. This is the tray water outlet. The tray water comes out right here, okay? That's where the tray water comes out, right there.
What water?
The tray water.
Tray?
Yeah,
Oh,
the picture
the
tray.
trays, yeah, okay.
The tray water comes out here. This is the flow that's going to go by gravity back to the aeration station tank, okay? The Venturi water that comes out of there, you know,
Yeah.
that's going to get collected actually at the bottom of this tray tower, the Venturi water. But it goes down and gets collected in the Venturi tank.
Yeah.
And this valve here is flow control valve. This is a flow control valve, yeah. Flow control. This here controls the flow of water going to this tray tower, okay? Yeah. This is where the sprays used to be, where we took these out and put in the trays.
Okay.
This is the transformer rectifier for the wet electrostatic precipitators right here. There's some disconnect there. You have to go in there with a safety key if you want to get access for maintenance. This device, we had to put a pan underneath it because it's filled up with transformer oil. Any leakage we didn't want to get could be a fire hazard.
Right.
So we have a safety pan underneath it. Okay. And from this device we have the electrical bus going up. This is supplying the high voltage to the fields in the wet electrostatic precipitator. Okay. Bunch of valves down here, remember?
Right.
Yeah, that's when we were pumping out, you know? We had to pump out, we had to...
The wire,
We had-
all got clogged up.
Yeah, no, yeah, we had to control the level in that tank, and that's why we had a control valve here, you know?
Yeah.
Now that we're gravity, we don't need any of that, so that's all gone. What you got here is this is the water, plant water coming in, okay? Flow meter here. See how much flow is going into the, and this goes up and into the tray water.
That valve up there. Open that valve, it'll open the gallon. When you open that, more gallons.
Yeah, yeah. That's the flow meter right there. We also, they've provided a shut-off valve here, automatic valve, where they can shut off the supply of plant water.
They can?
They can. Yeah. This valve here. The automatic valve, they can shut off the supply of plant water now. And anyway, here's the gravity drain line. Okay, you can see it coming around over here, all the way around, and this goes in now. It goes around. Why don't we go over here? Yeah. So this is where we've got the